In the previous video lecture, we have seen about the arithmetic, logical and data transfer instruction set of 8086. So, remaining instructions we will see now. Okay. So, remaining instructions are not instruction in logical, shift and rotate. So, shift arithmetic left, logical left, rotate right, left, with and without carry. These are the instructions belongs to logical set. Fine, we will see that now. The first instruction that we are going to see is NOT instruction with an operand mentioned. So, the operand can be mentioned using a register or from the memory, but the operand cannot be an immediate value. You are not supposed to mention an immediate value for this NOT instruction. Fine. So, we will see how this NOT instruction works. So, what this NOT instruction will do is it will invert the data in the register or memory mentioned in the operand field. So, it will invert bit by bit. Fine. So, we will see how this inversion happens. Fine. So, for example, I have taken an instruction NOT CX register or CL register. Okay, CX is for 16 bit, CL is for 8 bit. So, any of the 8 or 16 bit register you can take. So, for example, if CX is having the value 0506, okay. So, if we write this bit in binary, we will get the value like this. Okay. So, what this NOT will do is it will invert bit by bit. It will convert the zeros into ones and ones into zeros. Okay. So, this 1 will become 0, this 0 become 1, 1, 1, 1, 1. This will become 0, 1, 0, 1. This is 1, 1, 1, 1. So, what the value will be now? F, A, F, 9. So, this value will be residing in CX register now. Okay. So, if I mention a memory location, it will invert the value in memory location and stores the result again in the memory location itself. So, that is what NOT instruction will do. Okay. The next instruction is shift logical left or shift arithmetic left. So, what shift will do is, so this will shift the values in the register that we have mentioned in the instruction. Okay, the register or memory location, the values in that will be shifted bit by a count mentioned in CL register. Okay, so if you want to shift a value to a bits of 4, that 4 will we have to store in the CL register. So, once you have mentioned the shift instruction in a program, it will look into the CX register. Fine. So, how many values has been stored there? If the value, according to that value, the shift operation will take place. If there is 4 resides in CL register, then the shifting will happen to 4 bits or 4 times, whatever it may be. Fine. So, we will see an example for it. So, first I have mentioned a shift logical left, SHL, shift logical left AX. So, it is supposed to shift the value in AX register towards left logically. Fine. We will see it now. Okay. So, I have taken an example. If for an example, if I have an value 3A30, okay, then we are supposed to write that in bits. Fine. So, how we can write 3A300000. So, assume, so here you have your carry. This is your least significant bit. This is your most significant bit. So, now we are going to shift left. Fine. So, logical shift you are going to perform. So, bit number 0 goes to bit number 1. So, that is 0. Now, bit number 1 value 0 will go to bit number 2. That is also 0. So, bit number 2 to bit number 3. Fine. So, this will go to bit number 4, 0. Then this goes here. 1, 1, 0, 0, 0, 1, 0, 1, 1, 1, 0. The 15th bit will move on to carry. So, now the carry has 0. Okay. So, this bit number 1, 2, 3 and this bit number 6. So now the 0th bit has been empty. Okay, at that place, since we are performing logical left, a 0 value will be inserted. So here we will have 0. So this is for shift operation. When you are performing shift, here I have performed 1 bit shift. So only 1 bit I have shifted, right? So for this shift operation, so my 0th bit has been empty because I have performed left side shift operation. So a 0 has been inserted since I am performing logical shift. Fine. So now the result value will again be stored in X register. Okay. So if you want to perform 3-bit shift, in the sense CL register will have the value 3. Okay. Then this shift operation will happen 3 times, or 3 bits it has been shifted, which means that the 0 bit will goes to bit number 3. Then this first bit will go to bit number 4. This is how the shift will happen. Or so if you perform bit by bit 3 times, this shift has to be performed. So either thing is possible here. Fine. So next is shift arithmetic left, SAL. So this is also same like logical left. So the operation will happen like this. Here also 0 will be inserted. Fine. The operation is same, but the name has been given logical left, arithmetic left. So either of the cases 0 is going to inserted in the empty bit. Fine. So on the next instruction is shift logical right, SHR, and then you have to mention the operand. So as I have already told you, the operand can be of an register or it can be from the memory location. Okay. So here you are going to shift right side. Fine. So from most significant bit to least significant bit. So when you perform left, it will be from least to most. So here right, so it is most to least. Okay. So here also the number of shifts is mentioned by CX register. Fine. Okay. So here when you perform right shifting, obviously your most significant bit will become empty. So at this time, here 0 will be inserted since we are performing logical right operation. Fine. Logical left we are shift we are performing. So here 0 will get inserted at the empty place. Fine. So the shift will happen as of here also. Okay. So next instruction is shift arithmetic right. So those also the shifting will be same, but the value to be inserted at the empty place is 1. So in case of arithmetic right, we will see it now. So SAR is shift arithmetic right. Okay, fine. So here also right shift is happening to the bits mentioned in CX register. So it will be from most to least significant bit. So those things are all same. But the thing that's happening here is, here 1 will be inserted at the empty bit. So there at logical 0 got inserted, at arithmetic 1 is inserted. So as you have seen in left side shifting, both logical and in arithmetic, at the empty bit 0 is getting inserted. So but in case of right shifting, at logical for the empty bit 0 is getting inserted, for arithmetic 1 is getting inserted. So this is what will happen when you are shifting to the left and right. So now we will see the rotate instructions. Okay. So there are 2 kinds of rotate instruction. One is through carry you are supposed to rotate, and next one is without carry, without involving the carry bit you are supposed to rotate the bits. Okay, we will see it now. So first we will see rotate right without carry, ROR. So operand field can be of an register or it can be of an memory location. Fine. The values in the register or in the memory location will be rotated right side from most significant to least significant bit without involving the carry bit. So what will here happen is, so 15th bit to 14, 14 to 30, likewise the shifting will happen. From 0th bit to 0th bit is given to carry. So this till now this operation will be like shift right. Okay. The only difference here is the 0th bit again given to 15th bit. So that is the difference between rotate and shifting. So in case of shift, the 15th bit will become empty. So if it is a logical or arithmetic, based on this 0 or 1 will be inserted. So in rotate, what will happen is the 0th bit is given to the carry as well as to the most significant bit. So that is called as rotation. So now the circle has been completed. When you go for shift, the circle is not completed. So we are supposed to enter or insert 0 or 1 there based on the arithmetic or logical. So here in rotate, the 0th bit is again given to the 15th bit. Fine. So this is rotate right without carry. So next we will see rotate right with, that means through carry. What will happen here is, so here the rotation will happen from most significant to least significant. So 0th bit value is given to carry, the carry value is given to 15th most significant bit. So but here the 0th bit is shifted, 0th bit is given to 15th, but here carry is given to most significant bit. So that's the difference between without carry and with carry. So now we will see rotate left without carry. So here the rotation will happen from least significant bit to most significant bit. Okay. So how the rotation will happen? The 15th bit is given to carry, again the same will given to 0th bit in case of without carry. As of through carry, the carry is given to the most significant bit. 15th bit is given to carry, and then carry bit is given to least significant bit. So this is for rotation and shift instruction. Fine. So next we will see about string manipulation instructions. So the first we are going to see about REP, repeat. So this instruction we will use as prefix to most of the mnemonics of string manipulation instructions. So what is string manipulation in the sense, if you want to operate on a more number of data, so more number of numbers, so more number of your hexa values in a memory, we are supposed to use a string manipulation instructions. So for example, if you want to access 10 bytes of data from the memory location, we can use the string manipulation instructions. So what are all the operations that are possible on these number of data, in the sense you can perform move operation, you can perform compare operation, you can perform scan operation, and many such operations you can perform. Fine. So for to perform this, so you are going to, for move, if you are, for example, if you are performing move operation, you are supposed to perform it on a 10 bytes of data. So which means that you are supposed to execute that move instruction 10 times to perform that to perform or to transfer 10 bytes of data from one location to another location. So to perform that, to perform a particular instruction for number of times, we will use this repeat as a prefix of an instruction that has to be performed so many times. Fine. Can you all able to get it? So for example, I am saying it again, if you want to move a 10 bytes of data from one memory location to another memory location, you are supposed to execute that move instruction 10 times. Fine, right? Then only that 10 bytes of data will be transferred, no? Right? So to perform that, you have to execute that move instruction 10 times. So to involve that, we will use repeat as a prefix before the move instruction. So that this repeat instruction will make the move instruction to be executed repeatedly to perform that data transfer 10 times. So we will see how the repeat works now. So how it is used, if you want to, I have taken an example as move instruction. Fine. If you want to perform a move, a repeat will be given as a prefix. What this will do is, if you want, as I have already told you, I have to perform 10 bytes of data from one location to another location. So this 10 is a count now. So this will be stored in CX register. So what repeat will do is, initially this instruction will be performed once and the value in CX register will be decremented by 1. Okay. So what repeat will do is, it will check to CX register, check whether it has become 0 or not. Okay. If it is not 0, again execute this instruction. Okay. When it is again executed, this count will become 8. So again repeat will check whether it has become 0. If not, execute the instruction again. So this is how it will happen. So the instruction will be executed repeatedly until CX becomes 0. Once CX becomes 0, this instruction will will stop its execution and comes to the next instruction what you have mentioned in the program. Okay. So the repeat can happen in two ways, conditional repeat. One is repeat on equal, which means repeat on 0, repeat on not equal, or repeat on non-zero. So that's the thing here. So when we see next instruction, we will use this repeat. At that time you will understand it exactly. So this repeat instruction we will use only when we perform string manipulations and not on the other cases. So in normal data transfer you can't use that repeat as a prefix. When you perform string manipulations or before the string manipulation instructions, we are supposed to use the repeat as a prefix. Fine. So the first instruction that we are going to see in string manipulation is move SB or move SW. So this is nothing but move string byte or move string word. So byte is of 8-bit, word is of 16-bit. Okay. So move, you already know what the move will do is it will help for data transfer. Okay. So if you want to move string byte, which means that if you want to move 8-bit data, you can use move SB. If you want to move 16-bit data, you are supposed to use move string word. Fine. So as I have already told you, this instruction is used to move a string of byte or word in a consecutive memory location to other memory location. Fine. So I have taken an example here. So see here, you want to transfer from memory location 1000 to 2000. Okay, a string of values starting from the memory location 1000 to 2000. Okay, so how many bytes of data that you have to take from 1000 is mentioned in CX register. The number of bytes you want to transfer is mentioned in CX register. Fine. So the source address is mentioned in source index and destination address is mentioned in destination index. Fine. The offset value, exactly the offset value will be stored in source and destination index. Okay. So here I have taken as an example that if you want to transfer a data from the data segment to extra segment to 4 or 5 consecutive memory location, you can use these kind of instructions. Fine. So here in the program as an example, I have taken a data segment, okay, that is your source, and extra segment as your destination. So in the data segment, the offset value is stored in source index, and in extra segment the offset value is stored in destination index. So this is the condition that you are supposed to use only source and destination index register for storing the offset value. You are not supposed to use any of the registers here. Fine. Okay. So and then there will be a confusion that, so in this program I have taken 05, which means that, so which means that from 1000 5 consecutive memory locations has been taken and the value from that should be shifted to 2000. So that is the program here. So here you might have a confusion that from 1000 whether you have to increment and take the address or decrement and take the address. So there will be confusion, right? Because you have only mentioned the starting address and then the count of the address consecutive memory location that has to be taken. So that is what we have mentioned. We didn't mention that whether you have to take 1000, 1001, 1002 like this incrementing or decrementing fashion. So 0, 0, triple F, so 0, double FE, 0, double FD. So like this we are supposed to take. So that has to be also mentioned. So this we will mention it using the direction flag. So do you remember in the flag register we have a bit called direction flag. So this flag will mention the direction of taking the address whether by incrementing or by decrementing. Fine. So if the direction flag is 0, you can perform auto increment. So this will go 1001, 1002 like that. So if the value is 1, auto decrement will happen, which means that 0, triple F, 0, double FE. So like this will take. So now we will see this program as an example. Okay. So first 2 lines we have initialized the data on the extra segment. Okay. Then we have initialized the source index as 1000, destination index as 2000, and the value that has to be transferred, number of values to be transferred is 5, that resides in CX. Then CLD. What this means is clear direction flag. So clear in the sense now df value is 0. So 0 means auto increment. So which mentions that consecutive incremental memory location it will take. So next the instruction is move SB. We are performing byte string move operation. So what will happen, for example, okay, so since we have mentioned that direction flag is 0, so what we'll do is when first move SB has been executed, the 32 will be moved to 2000. So in 2032 will be stored. So again what will happen, since we have performed a repeat instruction, the next instruction to move will not be executed. Okay, so the repeat instruction will check to the CX register. Okay, so once the move has been executed, CX now has become 04. So the repeat will check CX whether it has become 0 or not. Now it is not 0 here. So what this repeat will do is again it will execute move SB. So now since we have cleared the flag, 1000 has been incremented to 1001. So 46 now stored in 2001. So again this value will become decremented 3 now. So again repeat will perform the same instruction. Direction flag is cleared, so address will be incremented again from 2000 to 1002 to 2002 it has been transferred. So this has become 2, this will be decremented, it is not 0, again the same instruction will be incremented, the next transfer will happen. So this will become 1 now, check to the value. Okay, this is not become 0, repeat will perform the same instruction, so address will be incremented and transfer will happen. So now CX has become 0. So repeat will check whether C has become 0 now. C has been become 0 now. So this instruction will not be executed now. The next instruction mentioned after this will be executed. Okay. So now can you all able to get the clear picture now? So string manipulation we will use when we want to perform on a string of data. Okay. So here we have first taken a move instruction. If we want to move a data from one segment to another segment, a number of data, we can use this move SB or SW. If you want to move 8-bit value, you can use SB. If you want to move 16-bit value, you can use SW. Fine. So the length of the string, the number of data to be transferred is mentioned in the CX register. Fine. So and then the source address is mentioned in source index and destination address is mentioned in destination index. That is the must thing. Okay, you can use repeat as a prefix to the move instruction to perform number of times it has to be executed. Fine. So the next string manipulation instruction is compare. So compare operation is same of normal compare instruction. It will compare two operands what we have mentioned in the instruction. So here you can perform a string byte compare or string word compare. Okay, so you can consecutively it takes the memory location and then it will compare. The length of the string is mentioned in the CX register. Okay, and the repeat you can use as a prefix to this compare string byte or string word to perform n number of times. Okay, so the compare internal operation is subtraction, that you know already. So the operation is same. While comparing, it will check to the carry or 0 flag to come to a decision whether the destination has been greater than or less than the source. Fine. So the next string manipulation instruction is scan string byte or scan string word. So what this will do is it will scan a string byte or string word in destination index. Okay, that to an extra segment it will scan whether the given data or whether the data it's searching for is available in that location or not. So that is what scan operation. Okay, so the data that you want to search you are supposed to store in AX or AL register. If you want to search an 8-bit data, you have to store it in AL register. If you want to search a 16-bit data, you have to store it in AX register. Fine. So as of move and compare, you can use repeat as a prefix here, and the length of the string up to which memory location you have to search the specified data is mentioned in CX register. So that's same here. Fine. Okay, so you can use repeat on not equal as a prefix of this. So on the direction flag, as you have mentioned, 1 means decrement, 0 means increment. So in what fashion you want, you can use it here. So that is what string manipulation instructions are. So we have seen repeat, move string byte or word, scan string byte or word, and compare string byte or word. So these are all the most important operations that we use in string manipulations. Fine. So next we will see about branch instructions. Fine. So in general we have seen the branch instructions in 85 itself. The same purpose is here. If you want to transfer the control of your CPU from one memory location to another memory location, you can use this branch instructions. Okay, so there are two kind of branch instructions. One is conditional, another one is unconditional. So first we will see about unconditional branch instruction. So unconditional branch instructions are nothing but without giving any conditions, the CPU's control will be transferred from one memory location to another memory location. Fine. So when you are performing the jump or unconditional branch instructions, you are supposed to transfer the program status into the stack. So this we have discussed n number of times while we are discussing in 85 itself. Okay. So now we will see the unconditional instructions of 86 microprocessor. So the first unconditional instruction is call instruction. So this call, and then you are supposed to mention an address here. So what the processor will do when it sees this call instruction is, it will call the instructions reside in the address and starts to execute it. So that is what call instruction will do is. So these instructions are used when you want to perform, when you want to execute a subroutine program. Okay. So before the processor jumps to this location, the status of the IEP is nothing but instruction pointer, code segment, then your register values are to be stored in the stack. Fine. So this we have seen already. So there are two types of call. One is near call, another one is far call. So near call in the sense, if you want to jump within the same segment within a range of 32 KB, then it is called near call. So far call in the sense, if you want to jump from one segment to another segment, that is called as far call. Okay. So I will recollect you once again. The call we will use when you want to execute a subroutine program. So before it executes that particular address location, it has to store the status of the main program in the stack. So that is what will happen when you execute the call instruction. Fine. So the next unconditional branch instruction is return instruction, RET. So what it will do is, it will return from the procedure. Okay. So this I will explain you with the call itself. So when you use call instruction, it will execute some main program. From the main program, it will jump on to the subroutine. Okay. So once the subroutine has been executed, again it has to return to the main program now. At that time, return instruction is used. When you want to jump from the subroutine to the main program, return can be used. So once it's returned to the main program, the status that we have stored in the stack should be retrieved, should be restored. So once the process is to this return instruction, before it jumps to the main program, it will retrieve all the values, IP, CES and register values stored in the stack. So once it has been retrieved, it will return to the main program. Fine. So the next instruction is INT N. INT is nothing but interrupt, N for type N. So here we have 256 interrupts, which is nothing but 00 to FF. So the N represents from 00 to FF, which means that we are having 256 interrupts. Okay. So once we have mentioned like this, interrupt 35H in the sense, it will, for each and every interrupt we have the subroutine, interrupt subroutine. For each and every interrupt, we will write a subroutine program for everything. Okay. So what will happen here is, once the process is to this instruction, it will calculate the subroutine address of this particular instruction. Since each and every interrupt will have its specific subroutine stored in a specified memory location. So first the processor has to calculate the subroutine's address, and then it has to jump to the subroutine to execute that program. Fine. Okay. So before it jumps to that particular location, all the status has to be stored in the stack. This we know already, fine. So now we will see how the address, subroutine address is calculated. So interrupt address can be calculated into type number into 4, okay. So for example, I have taken an interrupt int 20, okay. The interrupt address can be calculated type number, here it is 20 into 4, so we will get 80. So now it will go to the memory of 80 where the subroutine has been stored, okay. So here the code, since it belongs to the instructions address, you are supposed to access code segment. So the code segment register value is 0000, that is default, and IP value is 0080, this is here, and this is your code segment, and this will be your IP value, your ISR's address, and the processor will start to execute the instruction from this address, okay. So that's all about INTN, okay. So the next instruction is IRET. So this is written from ISR. So the before instruction that we have discussed is RET. So it is used just when we use call instruction, or if you want to execute a subroutine program, that's all. So this IRET is used when you are jumping to an ISR, interrupt subroutine. When you jump to an interrupt program, if you want to return to the main program, then you are supposed to use IRET, okay. So before processor jumps from interrupt subroutine to the main program, again the same thing has to happen. It has to retrieve all the status of the main program from the stack, and then only it jumps to the main program, fine. So the next instruction is unconditional jump, JMP, then address, okay. Here, so no conditions has been mentioned. So once the process sees to this jump instruction, it will jump on to the address that we have mentioned here. For example, if I have mentioned 5000, so without checking any condition, this will jump to the address 5000. So this is for jump instruction. And next instruction is loop, and you have to mention the address here. So what this loop will do is, it will execute a part of the program for CX number of times, which means that if you have mentioned 05 as CX register, so it will this loop instruction will execute some part of the program 5 times, okay. I will explain you with an example, okay. So this loop, what it will do is, it will decrement CX and check whether the CX has been become 0 or not. If it is not 0, then jump on to the label that has been mentioned. So the operation done by these two instructions is done by this single loop instruction, okay. See to this example, here CX is written with 5, AX with 25, BX with 5, okay. Now I am adding this AX plus BX, and result again will store in AX, okay. So again loop will get executed. What loop will do is, now it will decrement CX register. So CX now becomes 0, check whether CX has become 0 or not. So now it is not become 0. So jump to this loop 1. Loop 1 is nothing but this instruction, okay. Again this instruction will be executed. So this will be executed until CX has become 0. So assume that CX has become 0 now, okay. So now when loop checks to this, so CX has become 0, so this will not jump to this address, it will execute the next instruction. So the loop is used at any time, not only for the string manipulation, for any instructions you can use this loop, okay. This will do the operation of two instructions, one is decrement and another one is jump on no 0, okay. So next we will see conditional branches. So till now we have seen unconditional branches, which is without mentioning any conditions, the processor will jump to the address that is mentioned in the instruction. So when you go for conditional instruction, the processor will check on to a particular condition whether it is satisfied or not. If that particular condition has been satisfied, then only it will jump on to the particular location mentioned in the instruction. Otherwise, if the condition is not satisfied, it will not jump to the address mentioned in the instruction, it will execute the very next line, the very next instruction that has been written in the program, fine. So we will see such kind of conditional instructions, okay. The first conditional instruction is jump on 0 or jump on equal. So this instruction will check to the 0 flag whether that bit is 1 or not. If it is 1, it will jump on to the address mentioned in the instruction, otherwise won't. Next one is jump on 0 or jump on not equal. So again it will check the 0 flag. If it is 0, then it will jump to the address mentioned in the instruction, otherwise or not. So all these condition instruction only check the flag register, the bits of flag register. Okay. So next thing is JS, jump on sign and jump on not sign. If sign value is 1, then only it will jump. So this instruction, when sign value is 0, then only this instruction will jump. Next is jump on overflow, jump on not overflow. So this is overflow. This will check to the overflow bit of flag register. If it is 1, then this instruction will execute it. So this instruction will be executed only when overflow bit is 0. So next is jump on carry, jump on no carry. This you know already. This is jump on parity, jump on non parity. This is jump below or jump not above. Okay, if the given, when you are performing compare operation, okay, if the destination is less than the source, then this instruction will be executed. So this instruction will be executed only when the destination is greater than the source. When it is greater than the 0, then in this instruction will be executed. So these are all of the conditional branches. So these conditional branch instruction we will use depend on the application of our program. Fine. So next we will see about the flag manipulation instructions. So these instructions will affect a particular bit of the flag register. We will see how this affects the flag register now. The first instruction is CMC, which is nothing but complement carry flag. So what this instruction will do is, this will check the carry bit of flag register. Okay. If it is 0, then it will complement it to 1. So if it is 1, it will complement it to 0. That's the purpose of CMC. So the next is CLC, which is nothing but clear carry flag. If my carry bit is 1, it will make it to 0. That's the purpose of CLC. The next is STC, nothing but set carry flag. If the carry flag value is 1, it will make it to, carry flag value is 0, it will make it to 1. Okay. The next is CLD, which is nothing but clear direction flag. If the direction flag is 1, it will make it to 0. So next is STD, nothing but set direction flag. If the value is 0, it will make it to 1. So these two instructions we will use at the time of string manipulation. Okay. So this we have discussed previously, and then these instructions are used depending on the application. Okay. So if you have decided that if carry has been set, you are supposed to perform some other application, you can use this instruction. Okay. So the next is CLI, clear interrupt flag. Okay. So this interrupt flag is most important. Okay. If an interrupt occurs and if you want your processor to jump onto the subroutine to execute the subroutine program, your interrupt flag should be set. Unless otherwise your interrupt flag is not set, your interrupt program, that means your subroutine, interrupt subroutine, will not be executed. Okay. So to set and clear the interrupt flag, these two instructions has been used. So CLI is to clear the interrupt flag, STI to set the interrupt flag. Fine. So the next set of instructions are machine control instructions. So these instructions will control the bus usage and execution of program in the CPU. Fine. So the first instruction is wait instruction. So this will make the processor to wait until it gets the until the test signal has become low. Okay. So halt means it will end the processor execution. NOP is no operation. The processor will not perform any operation while it's executing NOP. Then lock instruction. This will make the bus lock instruction as a prefix. Fine. So these are all the instructions of 8086 microprocessor. Fine.